Well, happy Friday, everybody, and welcome to another 15-minute feature Friday presented by your Milestone Solution Engineering pre-sale team. My name's Stephen Moore. I'm a solution engineer covering the Southeast and the Atlantic regions here in the United States. Today we're going to be covering a topic of server encryption. A very simple topic, shouldn't take us very long. But as you'll see, I'm clearly joking about that. So basically, this is going to be about a 10,000 foot overview of server encryption. And because of that, this is I intend to give you as many resources available to you. And in order to do that, I've basically attached a link guide to this GoToWebinar. So on your control panel, if you expand it out and look in the handout section, you should see a PDF in there called the FMFF resources.pdf, for basically 15-minute Feature Friday resource. And on there, you'll see a single page of links on there, which are basically going to go in order of this presentation. So just make sure you save that PDF before the end of this if you are interested in getting some of these resources. They're all publicly available on our website, but they are scattered all over the place. So these are, I think, some valuable resources if you're interested in the subject. So the first question is why do we want to talk about encryption? Why are we covering encryption today? And to answer that, I think we really need to understand a little bit how the system interacts with each other, and the different layers that are required to create a secure connection between all the different layers. So to give you some examples, the recording server is responsible for connecting to our devices. So communication is going to happen continuously almost between the recording server and the devices. And this communication actually happens on a couple different layers too, a couple different protocols. Recording servers also are going to store video. So they may have to talk to a network-based storage device, a SAN, and NAS. Clients authenticate against our management server, and in turn, the management server has to grab configuration and write configuration to our SQL server. Smart clients also grab video directly from the recording server, which in turn may have to grab recorded video from network storage. Mobile clients, which are the web client and the mobile client, communicate directly with the mobile server, which in turn may also need to talk to the recording server for live video and may also need to talk to the network-based storage device for recorded video. Third-party Milestone community partner applications, such as access control providers or analytic providers, will talk directly to our event server over the MIP SDK. And this event server may in turn, let's say an access control event goes off, may in turn send a smart wall event to the smart wall and also send an alarm over to the smart client. So how do we go about securing the connections between all these different server components, especially when these architectures could range dramatically between a small system and a large system, a true distributed system and global system? We have tons of different architectures we can take with these different distributed services. So basically today we're going to discuss 4 different ways of encrypting encrypting your Expertex system. And those are broken up into the kind of 4 categories here: recording database encryption, device encryption, mobile server encryption, as well as what I'm going to call the Expertex service encryption or communications encryption, which also encompasses our MIP SDK or our Milestone integration platform. So you're going to see this slide a lot. So let's go back to that system communication diagram. How do we break those up? Well, the recording server, failover recording server, and devices all can be lumped together into recording server encryption. We do that over HTTP, which is either or HTTPS, which can be TLS or SSL. And we can also utilize SRTP in some cases. Data at rest encryption or database encryption. That can be done on the local recording server, but also if we're utilizing network-based storage or SAN storage, we may also be extending that off to other network-based devices. And we can do this over AES 256. We also have the ability to do database signing, which is done over SHA-2 hash algorithms. Mobile server encryption is kind of self-contained. We can do that over HTTPS, which can either be TLS and SSL. And this will be between the web client and the mobile client and the mobile server. So we have all this white space over here still on the left between the management server, the smart client, the smart wall, partner applications, even between the mobile server and the management server and the recording server. So how do we encrypt all that? Well, that's kind of done over the system communication piece, which we're going to talk about last. So those are kind of the four segments. I know it's not a pretty slide, but I wanted to illustrate kind of how these different segments are broken up. So these are four different topics. Let's dive right in. Recording database, encryption at rest. Our encryption at rest is available, has been available for a long time, actually. Only in 2017 R2 did we update those encryption algorithms. So we changed over to AES 256 for database encryption or file encryption. And we changed our hash algorithm over to SHA-2, basically just updated to modern standards. What you'll see here is a slice of the comparison chart, and you'll see that media database encryption and digital signing is only available on our XProtect Expert and corporate products. So what is encryption at rest or recording database encryption? Well, basically, it's the ability to encrypt the video that gets recorded. This is either the local video on your live drives, your local archive drives, or any NAS or SAN locations you may be archiving to as well. When you're setting up a storage profile, you have the option to turn on AES 256 encryption. You can either do this using a light or a strong encryption method. And basically, a light encryption will do video headers only, while strong encryption is going to do the entire video record. What you choose is really up to your risk tolerance. And the only real difference between them is the amount of CPU resources you're going to utilize performing the encryption. So basically, obviously, if you're only doing the headers around the video, it's going to use less CPU. And if you're doing the entire record, it's going to use a lot more CPU. We also have the ability to digitally sign video, and I highly recommend using this if you're using Expert at Corporate, because it's included and really does not use any CPU resources, and basically allows you to confirm that recorded video and exported video have not been tampered with or modified in any way. In other words, you can prove the integrity of the video in the court of law or at any time after, and you can verify these digital signatures inside of the smart client player after exporting. So that's about all there is to recording database encryption. The next thing we're going to talk about is device communication encryption. And you'll see here, device communication encryption is available across our entire product suite, both in our C code and our E code product lines. Secure Real-Time Transport Protocol, or SRTP, was first introduced in Device Pack 9.8. However, HTTPS has been around for much longer than that. So first, we're going to explore secure hypertext transport protocol encryption. And basically, we support over 3,000 devices in our device pack that have support for HTTPS communications. In order to use HTTPS, you first have to generate and or install a certificate on the device. So you're actually going to go to the camera or other network device, either create a self-signed certificate, or you can install a CI signed certificate on the device. Once you do that and you enable HTTPS inside of the management client, all authentication to the device, as well as all camera controls, are going to be sent over either SSL or TLS, depending on what's enabled. However, video streams are still going to be tunneled, at least by default, over the default unsecured RTP or RTSP stream. In other words, by enabling HTTPS on the camera, all you've done is secured the communication methods, but you haven't necessarily secured the video streams. Now, SRTP actually looks to solve that on the next slide. However, there is a method that you can utilize, and basically it is possible to tunnel RTP over RTP or RTSP over HTTPS. And we can do this by changing the streaming mode inside of the management client for that camera to utilize the HTTP protocol. So in other words, RTP, RTSP over HTTP. And as long as HTTPS is enabled, we're going to tunnel the video over HTTPS. Alternatively and in conjunction with, you can utilize something called SRTP, or Secure Real-Time Transport Protocol. This was introduced in Device Pack 9.8, so you have to have Device Pack 9.8. Preferably, you'll have a newer device pack. And we have limited support for SRTP. So basically not all cameras support this. So all the access devices with firmware 7.3 or higher will support this. And also a select number of Bosch cameras as well. So if you go to our website, go to this supported device list, sort by miscellaneous SRTP support, and you will see a list of all devices that support SRTP. The first thing you have to do with SRTP is enable it on the camera. So this screenshot's from an access camera. You have to basically go into the raw configuration of the access camera and turn on RTSPS. You'll allow it and enable it. And you should also note that it uses a different port number than standard RTSP or even standard HTTP. So note if you're tunneling across a WAN or something like that, you may run into issues. So you should note the port number here. Then once it's enabled on the camera, all you need to do is turn on the streaming mode to use SRTP. So basically, we'll change the streaming mode from the default. Most likely, the default would be RTP over UDP, and we'll change it over to be SRTP over UDP. So we're about halfway through here. And the next topic we're going to cover is mobile server encryption options. Now, mobile server encryption has been around for a while. However, there's been some recent changes in the 2019 R1 and R2 releases. Basically, mobile server encryption is supported across all C-code corporate products. So Essential Plus, Express Plus, Professional Plus, Expert, and Corporate. With 2019 R1, moreover, with 2019 R2, we've optimized the way the security works and the certificate management works for mobile servers. So the first thing we should note is as of 2019 R2, including the client, mobile client, Expert Mobile no longer supports self-signed certificates. So you can no longer utilize self-signed certificates. And that's for a number of reasons. In that resource list, there's actually a knowledge base white paper in there that actually talks about these resources. Self-signed certificates are still possible for the web client. This may be acceptable inside of a domain environment where you can trust self-signed certificates. However, there are some risks associated with self-signed certificates. And if you are utilizing push-to-talk, it does require a signed SSL certificate. Could be self-signed, but it does require a signed certificate. One of the biggest changes in mobile server 2019 R2 is we now utilize the Windows certificate store. So this allows us to automate certificate creation on the server itself. And this does actually allow us to utilize something called Let's Encrypt CA, which is a free open certificate generation site. And there's a guide in that PDF that will walk you through how to utilize some PowerShell commands that were created by some individuals on our support team to automatically request and renew these Let's Encrypt certificates. There are some considerations to take and to note around mobile client encryption, though. If you're not on a domain environment, you can run into some troubles when using certificates. In other words, you may have an internal and external host name. Also, you can utilize dynamic DNS, but there's some considerations to take into there, like NAT reflection and things like that. So those are covered in some of the guides that are in that PDF. And the last thing we're going to talk about is kind of the rest of the system, right? So we have these three specific pieces. We're talking about the rest of the ExpertX service communication using certificates. So what we're going to see here is all of our corporate products, all of our C-code products support full end-to-end encryption. So basically recording server, management server, communication encryption, and Essential Plus, Express Plus, Professional Plus, Expert, and Corporate. And these communication encryptions were introduced in 2019 R1. So kind of two scenarios here when we're talking about system service encryption. It's much easier to implement in a domain environment. If you have a domain environment, you can basically just add or configure a certificate authority role inside of your Windows server. This could be on a domain controller or anywhere. Basically, all you need to do is issue a root certificate. And then on each individual server, you need to request a web services certificate that contains the host name for that service. Because everything's on a domain, all of your clients, so this is going to be your smart clients, but this is also going to be all your MIP SDK integrations, because we consider those to be clients as well. They should automatically trust the root certificate because they are on the domain. So that's one advantage of being on a domain. Now, as we're going to see with a workgroup environment, this is my personal recommendation, but I kind of recommend getting a CA signed certificate. That way, it's already trusted by every client on the network. You don't have to go around and incorporate. You don't have to go around and trust the root certificate. It's already going to be trusted. But if you don't want to go that method, it is possible to use self-signed certificates. We first have to generate a root certificate. However, that root certificate is going to have to be trusted by all servers and all clients. So every client that connects to the system, including any third-party MIP integrations, any smart clients, and any services or servers that are running, all have to trust that same root certificate. Additionally, just like before, though, you're going to have to generate a certificate for each Xprotect server. And again, that host name needs to be in that certificate as well. We do have a certificate guide on our website, also in that PDF or resource PDF I provided with you, that covers this process. So I recommend taking a look at that. Just a note about MIP SDK integrations when using any kind of system communication functionality, encryption functionality. MIP SDK integrations have to be built with the 2019 R1 SDK. So in other words, if they're using the SDK 2018 R3 or older, they do have to rebuild their integration basically to support utilizing Milestone's HTTPS functionality. However, if they implemented it outside of the SDK libraries, then they may already have that support. It's just something to take into consideration. So these are our 4 different kind of categories we talked about: recording database encryption, which is at rest; our device communication, which can be done over HTTPS, but also be done over SRTP; our mobile server encryption, which is done over HTTPS; and our certificate-based service communication, which is also done over HTTPS TLS. So if you have any questions, I do recommend you put them in the chat or the question box, and I will take a look at that for the next couple minutes. But in the future, if you have any questions, you may also email them to us, presalesUS@milestone.us. And again, if you came in late, I do recommend taking a look at the handout section of the GoToWebinar and download that 15-minute Feature Friday resource PDF. There's a bunch of links in there for resources of things we covered. So I'll give everybody a couple minutes for questions. If anybody has any questions, please feel free to put those in. All right. Yeah, Josh, I can send over the presentation to you via email in a PDF format afterwards. Does enabling encryption on a camera negatively affect performance when using more than one stream? You know, Todd, I wish I could answer that question with a little more of a direct answer, but I really feel like that's a question for the camera manufacturer, because all of the encryption load is put onto the camera itself. The camera actually hosts the server. It's the one who actually starts the encryption methods. So really, it depends on the method that the camera is using. All my cameras in my lab, I've never had any negative experiences with turning on HTTPS or SRTP. But again, it's really a question for the camera manufacturer. So sorry, I can't answer that question a bit better, but just kind of how it is. All right, cool. Well, if anybody else has any other questions, just feel free to email us, presalesUS@milestone.us. Otherwise, thank you for joining us today, and you guys have a great weekend, and we'll see you next month, I would assume. Thank you. Bye-bye.